solve each equation. Part A, negative 2/3 times the quantity 3x minus 2 plus 1 equals x. We need to isolate x, which happens to be on both the left and right sides, but first we want to eliminate or clear the fraction. And that means multiplying both sides by 3. So we would have 3 times negative 2/3, which is then multiplied against the quantity 3x minus 2. Then we would have plus 3 times 1, and that's equal to 3 times x. Now on the left-hand side, the 3's each cancel one another down to 1. So what we really have is a negative 2, which we need to distribute into the parentheses. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is plus 4. Then we have the plus 3, and then that equals 3x. Now, of course, 4 plus 3 is 7, and we have x on both sides. Let's add 6x to both sides of this equation. In other words, negative 6x plus 7 plus 6x equals 3x plus 6x. The negative 6x and positive 6x add up to 0. On the right-hand side, 3x plus 6x is 9, so we have 7 equals 9x. Now we divide both sides by 9, and we get that x is equal to 7/9. Part B, 2z plus 1 all over 3 equals 3 times the quantity 1 minus z all over 2. We're solving for z, and that means we want to isolate z, but first we need to clear the fractions. We'll do that by multiplying both sides by the common denominator of 6. When we do this, the 3 goes into 6 twice and into itself once. And now think about this being in parentheses and distributing the 2. So 2 times 2z is 4z. 2 times 1 is 2. Now on the right-hand side, we can cancel 2 into 6 3 times and into itself once. We still need to multiply this 3 times that 3. That would give us 9 times the quantity 1 minus z. But we need to distribute that 9. And so what we have is 4z plus 2 equals 9 minus 9z. We have z's on both sides, and we have constants on both sides. So what I'm going to do is simultaneously subtract 2 from both sides and add 9z to both sides. So I would have 4z plus 2 minus 2 plus 9z, and that equals 9 minus 9z minus 2 plus 9z. Well, of course, on the left-hand side, the 2 and the minus 2 add up to 0, leaving us with 13z. On the right-hand side, we have the negative 9z and the positive 9z summing to 0. And then we have 9 minus 2, which is 7. And so our final answer is going to be divide each side by 13 and get z equals 7/13. For part C, we have 0.4 times the quantity 2 minus 3x, and that's equal to 0.5x minus 0.2. We want to clear the decimals. Now in this particular case, each decimal is a tenth, 4/10, 5/10, and 2/10. So we'll multiply both sides by 10. So 10 times 0.4 times the quantity 2 minus 3x equals 10 times 0.5x minus 10 times 0.2. Whoops, 0.2. 0.2. So what happens here, of course, is 10 times 0.4 is 4. So we have 4 times 2 minus 3x. On the right-hand side, 10 times 0.5 is 5 times the x, and 10 times 0.2 would be 2, so it's minus 2. Now, that's much easier because all of the numbers we're dealing with are integers. On the left-hand side, we need to distribute the 4. 4 times 2 is 8. 4 times 3 is 12. And it's, of course, x. So it's 8 minus 12x equals 5x minus 2. In this situation, I want to collect the x's on the right. So I'm going to add 12x to each side. At the same time, I want to collect the constants on the left side. So I will add 2 to each side. Let's use the vertical method where we say add 2 and add 12x to each side. So you can see I'm going to do it vertically this time. And that, again, the negative 12x and 12x sum to 0, so we have 8 plus 2, which is 10. On the right-hand side, the minus 2 and the positive 2 sum to 0, and we get 17x. Divide both sides by 17, and our solution is x equals 10/17.